Okay. Okay. So my name's Erin, and right now I work at Intel, and I'm the responsible minerals program manager there. And I'll get a little bit more into that and what that is. But first, I'd like to just start and talk a little bit about who I am. So this is me. This is actually me in the field working at my current job, taking a look at a mine in Kigali, Rwanda. This is my family. So my parents and my sister, who are we're all kind of STEM people, really. My mom was a math teacher, and my sister actually works at NASA currently. And I'm from Seattle, Washington originally. Here's a picture of it on a rare, beautiful sunny day. I currently live in Portland, Oregon with the husband and son mentioned, and I actually brought my son Quentin here along to be my assistant. He's currently a fourth grader here in Portland and is doing online learning. So I invited him to come along on this journey with me as well. And then we also have, let's see, probably need to minimize these. Okay. It was covering up the picture of our two beautiful cats, Charlie and Zelda, and I'm actually hoping they do not make an appearance with us today. So I'll kind of start just talking about my education a little bit and my background. And so, I kind of wanted to start in elementary school, where, that's really where you learn how to learn, you learn what you like. And early on, I always really enjoyed the science classes. I liked learning about how things worked. Chemistry, I mean, who doesn't want a chemistry set, right? You get to mix things together and make things happen. And also physics, I really loved motors and trying to make kind of, my own little robots work and things like that. But I really loved ancient history. So a couple of my absolute favorite subjects were learning about the ancient Egyptians. So I have that represented here with the pyramids. I've never actually been to Egypt myself, and I would still love to go at some time. And also Greek mythology. So my mom was always very interested in Greek mythology, and so she would read us stories, and we also learned about it in school, where we would learn about the different gods and goddesses back, the Greeks and the Romans. And so that was always stuff that I really loved, and it's still a hobby to this day. And so I think that there's a lot of things that you can enjoy and still work on your whole life, even though it's maybe not part of your regular job. So in college, I studied chemistry at Western Washington University, go Vikings. And then I ended up going to graduate school, and one thing I really missed in chemistry was kind of, really making things work. And so I ended up switching to go into more engineering, which is, to me, it's a little more physical and a little more practical and a little bit less theoretical. And so I made that switch. I went to the University of Arizona, which this is actually me only about 3 weeks ago. I was actually able to go back and visit my old laboratory and wander through the halls. So that was really a lot of fun. So some of the things that I really found challenging at school. So the first one is math tests. So I don't know if they've changed things a lot over the years, but I remember a lot of sheets like this, and we had to go through and do these as absolute fast as we could. And that was always hard for me. I will still say that doing math quickly in my head is still not my strong point. I love math now, which I'm going to get into, I think, on the next slide. But this was always very hard for me. I would see sheets like this, and I would kind of freeze up. So that was something I had to learn to overcome. The other one was drawing. And I actually really enjoyed art class, but I was not a natural artist. Some people could draw these beautiful pictures, like the painters on TV. I was not one of them. I couldn't draw people. As much as I kind of enjoyed doing art, I was always a little bit embarrassed of what I would produce. And so those were a couple things that were hard for me. So what really helped me on kind of both of these subjects is almost them coming together, is kind of seeing the intersection between math and art, two of the subjects that I did have a hard time with. So I want to talk to start with kind of on the math portion of this. And on this, I really have my mom to thank. So I mentioned before that my mom was a math teacher, and her idea of teaching kids math wasn't the, let's do a whole bunch of time tests of multiplication. That's stuff that you need to know, and that's part of it. But she also wanted to introduce me to the kind of more real world, more interesting areas of math. And so some of the things that really got me interested in math, one of them, the first one is M.C. Escher. So this is kind of a little clip of his interlocking lizards. So the tessellations by M.C. Escher, where you can see he was able to draw all of these lizards and using kind of mathematical concepts, make them all interlock together perfectly. And I grew up looking at Escher books and making my own tessellations, and that to me, I didn't really understand that was math. And she taught me, no, this is math too, not just the, 2 times 2 is 4 on a piece of paper. Some other concepts that we talked about. So, one of the things that she would do with my sister and I that we really enjoyed as well are shapes. And so, making geometric kind of 3-dimensional dodecagons and things out of paper. So these are made out of origami, and I actually still make some of these to this day. And going back to my love of ancient Egypt, I mean, the pyramids, there are a lot of mathematical principles that went into building those pyramids, and so really making those connections. And in nature, we would collect pine cones, and she would get broccoli flower from the grocery store and show kind of the spirals and the natural number patterns that were in nature. And so those kinds of things really helped develop my interest in math, more than just trying to do some arithmetic on paper. I want to also go back to the art thing, and I always thought I couldn't draw. And then in 7th grade, I had an art teacher that really, his kind of area of expertise was perspective drawing. And so in this, I didn't have to free draw trees and faces and people, but instead I could use tools to actually make more perspective, more mathematical, more architectural drawings. And so from that, I really learned to love to draw. It maybe isn't gonna sell at an art gallery, but I still learned that I had a way to actually be able to be an artist in my own way. And so I think that those things really kind of help me understand that even if I don't like things at first or think I'm not good at them, that there's ways to make those connections to things that I do like to really grow in those areas. Okay, so now I'm going to kind of turn to my career. And as I mentioned, I always really liked science. I ended up studying chemistry and then chemical engineering. And so at that point, I ended up going to work at Intel. And I started my career working in the factory, in manufacturing. And at this point, I'm going to call on my assistant here. So this is if I can get this out. So this is a silicon wafer. So you can kind of see it's very mirror-like, and you can see kind of, hopefully, that there's kind of many lines on here. Now, what'll happen is the wafer is made in this shape, and then after many steps, which I'm going to show you a little bit more on in a video, these lines are all cut up, and each of these little squares is something that's going to end up being packaged and put inside of your computer. And this is really what helps. This is what really allows me to be talking to you right now, is each one of these tiny little squares. And so what I'm going to do first is I'll go ahead and show. I'm going to move this over to here. And I'm going to show you how this pile of sand ends up in your computer. So it's first melted, and then it's pulled out. Let's see, yeah, so it's melted to being really, really hot. And then it's pulled out into this big solid ingot. And this is just basically a giant piece of glass that's then sliced up to all these individual wafers, similar to what I showed you. And this is bare, nothing's happened to it yet. And then at a place like Intel, we take and we keep processing this wafer. We do a whole bunch of stuff. We shine light on it. We etch it. We deposit many different metals. You can see all the little squares that I showed you. And what they're showing there are metal, like different metal lines, because metal conducts electricity. And that's going to be important for what I talk about next. And that there becomes the brains to your computer. Okay, so my first job, so you can see everything is done on a very, very tiny scale. And so in my first job, if you have any kind of tiny little particle or any type of defect that that gets on there, that's going to affect how your computer runs, really. And so my job at that point was to look at all of these tiny little defects under a microscope and try to figure out where they were coming from and get rid of them, basically. So I did that for 10 years and decided it was time for something new. And so I had another job in between that was still focused on that quality. And then I transferred into where I work now, which is, you know, I mentioned the metals that we use. So the kind of shape of the wafer, it came from sand, but there's also many, many other materials that are present, you know, to make up each of those chips. Metals and minerals that come, you know, straight out of the ground are another one. And so now what I do is work on ensuring that that when we get those minerals, that we're not hurting the people and in the environment that they come from. Okay, so now I'll talk a little bit more, since it being Earth Day. Happy Earth Day, everyone. And I'm going to talk a little bit about how engineers can help the planet. And there are really so many ways that engineers can help the planet. And I picked three to kind of mention. So one of them is helping create more renewable energy. So I'm sure you guys have all seen by now these big kind of wind towers. So this takes you know, the natural wind that's occurring on the earth and turning that into power that we can use to power everything from our houses and our lights to, you know, charging our cell phones. All of that stuff can be done with wind and also with solar energy. So using what's happening already, we have, you know, using wind and water and light in order to get that energy. And so that we don't have to drill as much into the earth and take and take oil and gas and things like that. So some other work that Intel actually was working on was saving the bees by attaching chips to track their behavior and using big data analytics to develop solutions. So, so humans, we live on this earth and we have an impact. And one of the impacts has been less honeybees. And without honeybees, really, nothing is gonna survive. And so really working to try to understand how we can keep this species thriving. Another thing is designing systems to keep our rivers and lakes clean. So, designing different ways to reuse water and to clean water and things like that is really important work that engineers also do. Okay, so now I'm going to kind of go back to some of the work that I do now and our sustainability efforts. And so in my specific role, I mentioned that we're working to ensure that the minerals and metals that are used in Intel processing is really respecting the rights of all of the people on the planet that help get it there. And so I'm now going to show another video. So all of these pictures were taken on a trip that we took in late 2019 to Rwanda. And a lot of the miners and the mineral processors that we met along the way. And with that, I'm going to go ahead and show another video that was done of the trip that my boss and I took. So let me scroll down to that one.
A team from Intel Oregon traveled not long ago to Rwanda.
Erin, can you increase the volume?
Mines in Rwanda.
Can you increase the volume?
Yeah, let me see.
Sure. Tin, tantalum, and gold. The team's aim to help Intel and the entire technology industry guarantee the minerals we use in Intel products are sourced responsibly.
We're here in Central Africa, where many of the critical minerals for electronics industry come from. We're here to learn. We need to understand what's happening. We need to know what's going on.
In recent years, Intel and other tech firms were successful in eliminating human rights abuses, such as forced labor from the mineral supply chain in the Congo. But there's more work to do.
Intel came off to a very strong start in the conflict minerals space, and we were a very early leader. And so we want to take that leadership that we had early on and really expand.
So what is responsible sourcing? Here are the key questions. Are mining conditions sustainable and ethical? Are miners' rights respected? And can minerals be traced to a source that is legal? Intel has joined with Apple, Google, Facebook, and others to lead responsible sourcing across the industry. One major strategy is called bag and tag. Inspectors carefully track bags of raw mineral ore to make sure the minerals were mined legally and ethically.
We make sure that the production collected, mined, processed from all this through is tagged and
bag and tag is being widely adopted and is a stamp of approval for sellers, buyers, and investors.
And it helps the investors know they're not investing into unsafe practices, unfair practices.
The bottom line is just to make a sustainable business. So it can't be sustainable without traceability at this stage.
Intel takes responsible mineral sourcing seriously. Among its 2030 corporate responsibility goals, Intel will expand its efforts beyond conflict minerals to cover all minerals used in semiconductor manufacturing and lead the industry in creating new sourcing standards.
Long term, we hope to accomplish a fully responsible supply chain that